Alright, so today we're going to focus on Chapter 13, Section 3, and we're going to finish that up and talk about solids, and that will finish up our notes on the properties of solids, liquids, and gases, or the different states of matter. So you'll want these notes out. The front page should look like this, and we'll flip to the back page where we will talk about solids. Okay. So we're going to start here, and we'll fill in these notes, and then I have a little lab activity planned that we'll get to, hopefully, and then we will be on our way. So let's go ahead and get started. We are going to talk about solids, and solids are obviously different than liquids and gases in the sense that solids are pretty dense, they're harder, they don't flow. Liquids and gases had some similarities. Solids are kind of very different from those two. So let's go over a few of the properties of solids. So solids have a definite shape and volume, and what we mean by definite is that it's a fixed shape and a fixed volume. So whenever I have a solid, I know it has a set shape, it's not going to change, and its volume won't change. It is fixed in the position that it's at. Now, the reason that solids have a definite shape and a definite volume is because they have very strong attractive forces between the little particles within that solid. Now, this will allow certain things to be solid at room temperature. So if I have the right combination of elements together and they're very, very attracted to each other, then they'll become closer and closer together, thus creating a solid. Some substances are more stable and are liquids at room temperature, so the forces of attraction, the particles aren't as attracted to each other. Those forces are a little bit weaker. And with gases, we talked about there were no forces of attraction, so the particles didn't really care about each other. They just kind of slipped past each other. They weren't attracted, so they had kind of a big space that they filled out. Solids have the strongest forces of attraction out of all three, so that's why they can be solids at room temperature. Now, when we have a solid, we have obviously limited movement between our particles because we have a fixed shape and a fixed volume. Now, because we have a fixed shape and a fixed volume, basically that means is our particles are fixed in a certain spot. They're kind of locked in. Hence why we have a solid. When we have those fixed locations for our particles, we get a certain type of order. So we get kind of a pattern that becomes produced, and we have an ordered arrangement between all of the pieces. Now, solids are obviously fairly heavy most of the time, and typically if we have a solid, it's obviously more dense than a liquid version of that material or a gas version. And again, that's because the particles are so attracted to each other. So that's why we get dense, fixed solids. Now with gases and liquids, since there was some space between the particles and they weren't as attracted to each other, I could kind of compress them. So if I have a gas and I put some pressure on that area where the gas is, I can push the particles closer together because there's so much open space between them. Same thing with a liquid. Okay, the particles aren't as attracted, so there's a little bit of space. I can push them together. So when I apply pressure, the overall volume that gas or liquid filled up kind of decreases. So the more pressure I had, the less space those things took up. I was just kind of pushing them closer together. With a solid, we don't have that. So if I have a solid piece of something and let's say a brick, and I exert pressure on that brick, what typically happens? Well, the brick usually, if I have enough pressure, it might break in half. So I still have both halves of the brick. I haven't taken down the volume at all. I still have the same amount that I started with. I just have it in two pieces instead of one. So when I have a solid, if I exert pressure, usually the volume of the solid doesn't change. It just looks a little bit different. Okay, there are two types of solids, and you'll have to know these words and be able to differentiate between the both of them. And the first type is a crystalline solid. And I'll let you go ahead and fill your notes in. Alright, a crystalline solid basically just means we have a 3D shape, and it's since we have an ordered kind of arrangement of my particles, I have this repeating pattern over and over and over between the elements in that compound, I get sort of a 3D shape, and we can use those shapes to identify different types of solids. So a lot of times with rocks and minerals, the way certain rocks and minerals form, they'll form in different shapes and in different shapes of crystals. So for example here, this would be a cubic type of crystal solid because this face right here on this crystal is a square. So we call that a cube. So each crystal has a cube shape. Here, this one is a hexagonal type of crystal, and I know it's a little hard to see here, but if you can see, kind of a hexagon has 6 sides, so if you can see the bottom part of these here is kind of part of that shape of the hexagon. And same thing here, this is a variation of kind of the hexagon crystal. So we can use those names to kind of figure out what solids we've got, and some of these structures may be more stable than others. The hexagon one is fairly stable, cubic one's not as much, so those kind of have their place there. But those are crystalline solids. Now in your book there's a diagram of this, and you've got it right there in your notes, but here are the different shapes we can get. This was a cubic one, so basically if you look at a crystal and you see a square on one of those faces of the crystal, then you know you have a cubic structure. These two are fairly similar, so I wouldn't dock you any points if you didn't, get the difference between these two. Basically these, we kind of have a rectangle on the face of it, and maybe a square kind of on top of that 3D shape. So typically a rectangle face and then kind of a square. This one is all rectangles on the sides of it, so orthorhombic is what it's called. This one is rhombohedral, just means you have a rhombus or kind of a slanted square on one of the faces. Okay. Monocyclic, this is going to be basically kind of the same shape rectangles on each side. This one is triclinic, so again kind of that rhombus shape, and then hexagonal, which obviously has a hexagon somewhere, usually on the top, and you can see there's 6 points here along the outside edges that make a hexagon at the top. Alright, so the other type of solid is obviously something, if crystalline solids are have an order and a pattern, then the other thing that we've got does not have an order and a pattern, and those are called amorphous solids. So I'll let you go ahead and fill in your notes. Okay, so amorphous solids basically means, you don't have a pattern. Everything's kind of mushed together. And a lot of and amorphous literally means without shape. So a lot of times the substances we have that don't really have a shape are glass, rubber, certain plastics. We get these really long chains of molecules that string together, and you can see that in this picture here. And there really isn't an order. They just kind of all string together and hang out, kind of like a pile of spaghetti. They don't really, there isn't a predictable pattern like there is in the crystal solids. So for example, down here, I believe this was a screenshot of rubber, a certain type of rubber or plastic that I took. Down here I have a crystalline solid. So here I can see I have kind of that hexagon shape right here, kind of those 6 points, and it's a repeating pattern. I know what's going to come next. It's the same pattern over and over. Here in this type of glass, there's maybe a little bit of a pattern, kind of similar to this, but in the large sense, not as much. It's more mixed up. Here we can see a little bit of the pattern, but it doesn't really hold throughout the entire thing. Now, when I have a crystal, and if I have like a molten or a melted substance and I cool it, I can get these crystals to form, and I can produce the ordered arrangement if I cool it really, really slowly. So that gives time for all the molecules and atoms to line up in a stable location, and they kind of get locked in. But if I cool things really, really fast, the atoms don't really have a chance to move where they want to, so they just kind of cool in the spot that they're at. So I may not get a very good crystal shape. So those are the two types of solids. Here's what you're going to do next. You have the teacher may have, or you may have picked up already, the identifying solids worksheet. It's just a chart. In the back of the lab, I have different types of rocks and minerals and some screenshots of kind of the molecular structure of different solids. And what I'd like you to do is obviously write down the name of the solid so I know what station you've been to, and then identify what type of solid it is. So you're going to tell me, is it crystalline or amorphous? And if it's crystalline, try to tell me which shape it is. So for example, tell me which one of these types of shapes you think it is. So kind of examine it really close. You can pick them up, you can touch them. Just make sure you don't drop them or break them. Obviously don't throw them. That would not be okay. Just go ahead and look at the faces, kind of see if you can find kind of an individual crystal and try to predict kind of what shape it's got based on kind of the face that you can see. So you'll fill those in. For your homework tonight, once that's complete, I want you to turn in your identifying solids worksheet, and then for your homework, I want you to finish up your mind mapping. So you're going to do solids, and that'll be done. I'll be checking those on Monday when I get back. And then the vocabulary sheet up until amorphous solids. There are extra terms on the vocabulary sheet. The chart, we haven't covered those yet, so just go up to amorphous solids. So it's all the way from gases all the way through the solids. And you'll be, on the chart, you'll have a column where you'll write the definition in your own words, illustrate it, and then use it in a sentence on the last column. And I will check the vocab sheet and the mind maps on Monday. Just make sure that you turn in your lab sheet from identifying the solids today before you leave. If you get any of these worksheets done after the lab activity, go ahead and turn those in as well, so those are in a safe spot, and that'll be fine.